ना Good afternoon, everyone. Greetings from VIDYAVARDHAKA College of Engineering, Mysuru. I, Madhushri, Assistant Professor, Department of Civil Engineering, signing in as Master of Ceremony for today's webinar on Aditya L1 Mission, Most Ambitious Venture to Sun, organized in connection with the birthday celebration of Konstantin Edwardovich Tsiolkovsky, Russian and Soviet scientist. I now request our beloved HOD, Dr. S.K. Prasad, to welcome everyone to the session. Over to you, sir.
Thank you, Professor Madhushri. It's a great pleasure for me to do the duty of welcoming everybody for this webinar and then telling a little about my institution. Am I audible? Hello? Okay. I'm sorry. Yeah. So I again would like to mention that I have a great duty to perform, that is welcoming everybody for this webinar, and then to tell a little about my institution. First of all, I wish to welcome my good friend, Professor MOHAN KRISHNA. Well, I always treat him as Sarvagnya. He's a great achiever and he is an excellent human being. And he always thinks of helping anybody who needs it. In a short, duration, over about 3 months' time, I have been in contact with him. I have really been impressed by him and I have become his fan. So, Professor MOHAN KRISHNA, it's my humble request for you to do a great job today, and I welcome you to this webinar. Okay. Secondly, I need to welcome all the participants. Civil Engineering Department at VIDYAVARDHAKA College of Engineering has, a lot of audience. Over the last couple of months, we have had about 25 webinars. In each of these webinars, we had participants, from amongst students, academicians, researchers, and working professionals, numbering, huge. Sometimes, we had 4,600 participants. I'm very sure today also we'll have many participants, both, attracted by Civil Engineering Department as well as by Professor MOHAN KRISHNA. I welcome each one of you for this webinar. Well, thirdly, I need to welcome my beloved colleagues from the Department of Civil Engineering, also from outside of the department in VIDYAVARDHAKA College of Engineering. So both teaching and non-teaching fraternity, I welcome each one of you. I just would like to tell very briefly about my institution, VIDYAVARDHAKA College of Engineering. It is in the heart of city of Mysuru, extremely popular, and it is the best choice of every student in seeking admission to both engineering and MBA programs. I'm very happy to mention that, from this year, 2020-21, our institution has become autonomous under Visvesvaraya Technological University. Our institution has 7 undergraduate programs, including the newly joined computer science, artificial intelligence and machine learning, and others are, computer science, information science, electrical engineering, electronics, and mechanical engineering, of course, civil engineering also. All the undergraduate programs are accredited by NBA, and the institution is accredited by NAAC with an A grade. So that clearly shows about the quality of the institution. I'm also very happy to inform about civil engineering, Department of Civil Engineering, which is only 7 years old in this institution. It started in 2013. I'm very proud and happy to mention that we have an excellent infrastructure, both in the laboratory part and then, seminar hall, computer center, and we have very good teaching learning ambience and extremely student friendly environment. And what I'm really proud about is my faculty. We are 17 strong in our family of civil engineering. We have a very healthy 1:14 teacher-student ratio. All teachers are well qualified, dedicated to work, and we have teachers from almost all the disciplines of civil engineering. And I also I'm proud and happy that our non-teaching faculty are also highly qualified. So with this, I welcome each one of you to our department, and it will be a pleasure to have you here and show you around. And now it's my duty to hand over to the MC, Professor Madhushri, for continuing the process.
Thank you, sir. I also extend a warm welcome to you also. With this note, I would like to remember and put a light on the achievements of the scientist Konstantin Edwardovich Tsiolkovsky on the occasion of his birthday celebration. Konstantin Edwardovich Tsiolkovsky, born on 5th September 1857, was a Russian and Soviet rocket scientist and pioneer of the astronautic theory. He is considered to be one of the founding fathers of modern rocketry and astronautics. Engineers and contributed to the success of the Soviet space program. Tsiolkovsky stated he developed the theory of rocketry only as a supplement to philosophical research on the subject. He wrote more than 400 works, including approximately 90 published pieces on space travel and related subjects. Among his works are designs for rockets with steering thrusters, multi-stage boosters, space stations, airlocks for exiting a spaceship into the vacuum of space, and closed-cycle biological systems to provide food and oxygen for space colonies. It's a great pleasure to hold this session on the occasion of the celebration of the great rocket scientist. I now request Professor D.P. Mahesh to kindly introduce today's speaker, S.A. Mohan Krishna, to the gathering. Over to you, sir.
Thank you, ma'am. Dear participants, good afternoon to all of you. It gives me immense pleasure to introduce about today's speaker, Dr. S.A. Mohan Krishna. Dr. S.A. Mohan Krishna is a person with humbleness and simplicity in approach and positively ambitious in life and ply with pragmatic thoughts. He completed Bachelor of Engineering from one of the prestigious institutions in Mysuru, that is VIDYAVARDHAKA College of Engineering, popularly known as VVCE, in the year 2003. He did MTech in Energy System from SJC Mysuru in the year 2010. Presently, based at University of Science and Technology, and completed PhD from the National Institute of Engineering Mysuru in the year 2017. He has published over 90 papers in peer-reviewed international journals and has presented papers at Qatar, Bangkok, and Singapore, and also in various parts of Karnataka. He is in the editorial and review board for over 100 reputed namely Scopus, Essay, Web of Science, Elsevier, and Springer. Earlier, he had authored 3 books in the stream of engineering with the titles: a textbook on cryogenics, a textbook on illustrative problems in engineering thermodynamics, and a book for competitive examinations in the mechanical engineering. He also the research supervisor and is currently guiding 3 research scholars, project proposals, consultancy, outreach, research publications, book chapters, and patent having favorites of you. He is a life member and a member of our Indian Society for Technical Education, Institution of Engineers, Indian Society of Mechanical Engineering, Society of Automotive Engineers, and Indian Society of Heating, Refrigerating, and Air Conditioning Engineers, Associations of Ammonia Refrigeration. Apart from the profession, he is recognized amateur astronomer and a freelance science writer. He is keenly associated with Mysuru Astronomical Society, International Astronomical Union, Paris, Astronomical Society of India, Breakthrough Science Society, Karnataka, Rajya Vijnana Parisat, Mysore Science Foundation, Gravity Science Foundation, Indian Academy of Science, Material Association of Science Education, Bangalore Astronomical Association of Science Education, and Rotary International Foundation, Computer Society of India, and many other science societies and service-oriented associations in popularizing and communicating physics, astronomy, and astrophysics, cosmology, social service, outreach, and essence of engineering. His hobbies include astrophotography, numismatics, outreach activities, observational astronomy, and science communication and popularization. He is a recipient of NIE Gold Medal, Dr. Raj Achievement Technology Award, Bharat Ratna Sir M. Visvesvaraya Achievement Award, Dr. APJ Abdul Kalam Achievement Award, Dr. S. Radhakrishnan Educational Award, Dr. Satish Dhawan Excellence Achievement Award, Sir C.V. Raman Lifetime Achievement Award, Dr. Raja Ramana Award, Dr. U.R. Rao Achievement International Excellence Award, Dr. M.G.K. Menon International Excellence Award, Outstanding Performance Award, IARE Award, Professional Excellence Award, and many more, which have been conferred to him in the field of science, education, engineering, astronomy, and technology by the various prestigious and premier associations and organizations. He has been given 3 honorary doctorates by 3 universities. He has given over 150 programs in television and radio too, and has delivered over 700 talks in science, education, engineering, astronomy, and general topics. Contributed over 2,000 science, technology, and astronomy articles in popular newspapers, magazines, and periodicals, and is comprehensively aiming to reach greater heights. So, with this, I welcome to our today's speaker, Dr. S.A. MOHAN KRISHNA. Over to Madhushree.
Thank you, sir. Without any further delay, I would like to hand over the session to Professor Dr.
Good evening, everyone. It gives me a great pleasure in talking to you all about one of the most ambitious topic, Aditya L1 Mission, which is one of the outstanding ventures towards Sun by prestigious organization. Dear friends, before I start, it gives me a great pleasure in thanking the Department of Civil Engineering of VIDYAVARDHAKA College of Engineering in giving me a fabulous opportunity in delivering a talk or interacting about the most ambitious venture, Aditya L1 Mission. The comparer of the program, Professor Madhushree, introduced one of the propounders of rocket science or rocketry, Konstantin Eduardovich Tsiolkovsky. He is regarded as the father of modern rocketry principles. From 1857 till date, the accomplishments in the field of astronomy and space science have been phenomenal. Before we take up the actual topic, Aditya L1 Mission,
For about 2 to 3 minutes, we shall have a cursory glance or review about the stupendous contributions in space science by Indians. Last year, we could commemorate the centenary birth celebration of the most esteemed scientist, space scientist of the previous millennium, Dr. Vikram Ambalal Sarabhai. He has been instrumental in initiating many astounding ideas in space science and technology. After 1960, Indians have become very popular in actuating many of the ideas in space science and technology. And for about past 50 years, Indians are almost at the top in contributing towards space science and technology. Just 10 to 12 years ago, India's prestigious space organization or global wide popularity for ISRO, one can definitely remember. Indian Space Research Organization has been exceedingly active over past 2-3 decades in contributing many achievements towards space science. In 2008, if you can remember, India's one of the most ambitious ventures started, Chandrayaan-1. After Chandrayaan-1, ISRO planned for many other space ventures, ASTROSAT. Next, MOM, Mars Orbiter Mission. If you can remember, it is really performing well. After that, Chandrayaan-2. So Chandrayaan-1, Chandrayaan-2, even though it was not extraordinarily successful, ISRO has played a pivotal role in contribution towards space science and technology. But today's topic of discussion is mainly on Aditya L1 Mission, the most ambitious venture towards sun. All may be discombobulated or flummoxed in just listening to the topic. Is this really possible? Earlier, a decade ago, ISRO took the initiative in embarking a mission to moon. It was very popularly recognized as Chandrayaan-1. 1 year it could work successfully, but due to technical snag, it was unable to perform. Later on, as just revealed, Mars Orbiter Mission, ASTROSAT, Chandrayaan-2. Now, people of ISRO are heading towards sun. Don't you really think this is the most ambitious venture from ISRO? Yes, friends. That is why just discussing about the past achievements or the present achievements, there is no point in presenting. If we know the information about the future endeavors, each and every participant will be fascinated or captivated towards the achievement in the field of space science, astronomy, and space technology. Fine, let me start the session officially. This is the first image what I am very much interested to speak on. This is the planned venture. Aditya L1 Mission, the venture to sun. When exactly this possible? What are all the objectives of this? what are all the payloads, which are all the research institutes who are all very much supportive for this venture. That is the topic of discussion for this particular webinar. We shall try to see each and every information very meticulously and in a very persuasive manner. So this is the idea wherein one can get how exactly Aditya L1 mission has been conceptually designed. Okay, we shall move further. Directly focusing on the objectives of Aditya L1 may not get a comprehensive idea in you. As just revealed, Aditya L1 mission, it is heading towards sun. When exactly this planned, we will try to know. Before that, for about 5 to 10 minutes, we shall know some information regarding the universal star sun. When you see to this image, everyone will get the idea about what exactly is this. This is the exact portrayal of the universal star sun. When we just see to sun, each and every one will be amazed, perplexed. What exactly is this? What is the composition of this? What are all the characteristics? What are all the composition? Many more fascinating questions will mesmerize everyone. To know some information, directly what exactly is sun? Sun is a universal star. It is regarded as ball of fire. This mainly comprises two gases, hydrogen and helium. In addition to this, we have many more gases in the photospheric region. Additionally, just presenting sun as a universal star will not amaze any astronomer or amateur astronomer. We have to be very clear. Sun is a G-type main sequence star. That is the exact definition what we can furnish for sun. Okay? To know more about sun, one has to closely have affinity with an amazing and celebrated subject, solar terrestrial astronomy, or in a colloquial context, solar astronomy. A solar astronomer is one who will be completely involved in the comprehension of sun, particularly sun. Fine. If we know few information relating to sun, it will be easy for us to comprehend what are all the objectives, what are all the prominent objectives of Aditya L1 mission. Friends, to know more information, let me move on to the next slide. Sun, as I said, it is a G-type main sequence star. To know more about this, one has to have idea regarding the observational data, orbital characteristics, physical characteristics, rotation characteristics, and general characteristics. If you are all well acquainted with these characteristics, then we will get more idea regarding solar astronomy. But the topic of discussion is mainly on Aditya L1 mission. In order to link this information, I am giving some rudimentary ideas about the characteristics of sun. Fine. After getting acquainted with these characteristics, one has to be aware of what exactly the visual and absolute magnitude of sun. Magnitude, generally speaking, the brightness. The visual brightness or magnitude of sun is minus 26 and the absolute magnitude is plus 4.23. You may be amazed why I am using the sign convention here. If the magnitude or the brightness factor of any object is negative, it is absolutely bright. But if the value positive is indicated, the brightness factor is low. So remember, the visual magnitude of sun is minus 26. Additionally, after getting idea about the visual brightness and absolute magnitude, one has to be aware of the mean distance between sun and earth. Please remember, it is exactly 1 astronomical unit. But for a layman, what exactly is this astronomical unit? He will be perplexed. 1 astronomical unit is equal to 15 crore kilometers. That is the distance between sun and earth. After gathering few information regarding sun, before moving to the actual topic, Aditya L1 Mission, we should be aware of the general characteristics. I told about rotation characteristics, orbital characteristics, and the general characteristics. So, orbital, rotational characteristics, they are purely astronomical. But for a common person, please remember the general characteristics involved with the principal composition. What are all the important parts or ingredients in sun? You all know that it is a G-type main sequence star. But what are all the principal components in the universal star sun? Friends, when you just see to this image, you will get the idea in a very comprehensive way. To begin with, the first principal component is core. It is regarded as barysphere. Core is the first part. Next, radiative zone and convective zone. Later on, in addition to this, we take up photosphere and atmosphere. These are the principal ingredients or parts in sun. But is this all? In this particular image, you will get many more fascinating ideas. But which is very much important for this session, we shall take up. All right. When we just see to this exploded view of sun, we will get more information. Even though there is core, radiative zone, convective zone, generally speaking, people will bother about 3 principal components. Which are that? Let me take up one by one. The first and the foremost, that is photosphere. Photosphere, as the name clearly indicates, photo meaning light. Solar radiation, which is directly incident to the earth, we are very much bothered. So, photosphere, followed by the next image, chromosphere. Photosphere and chromosphere, they are brothers of sun. Without which, it may not be possible for the universal star to function in a very unique manner. Fine, photo clearly indicates light. But what exactly is this chromosphere? Chromo clearly depicts color. So light and color, they are very much important in the solar radiation concept. All right. So photosphere and the chromosphere, they are very principal. But the most amazing, the most discombobulating component in sun is undoubtedly, evidently or obviously solar corona. When I just articulate the name corona in this context, majority of the people will lead to confusion. You all definitely remember the existing or ongoing pandemic coronavirus or COVID-19. In Earth, we have corona. But even in the universal star, the main sequence star, we have solar corona. This is general corona, that is solar corona. Fine, you just see to this image of solar corona, that is absolutely overwhelming. What exactly this corona? What exactly the emphasis? Friends, during the time of total solar eclipse, everyone will be privileged to see to solar corona. During the time of partial or annular solar eclipse, you will not be in a position to see to solar corona. But once in a location when total solar eclipse is eventuating, majority of the astronomers will rely on the depiction or portrayal of solar corona. All right. Before we take up the exact topic, few more information we need to say. Why I am focusing on solar corona? That may be one of the objectives of the mission Aditya L1. Solar corona, two more information I wish to convey. The first ever solar corona was observed in 1724 by a French-Italian astronomer Giacomo Filippo Mardani. And later in 1806, John Joachim de Federer Cafranga coined corona very exorbitantly. So since 1806 till date and even in future, we refer the aura of plasma of sun corona. Why corona in the context of astronomy and space science? Very important. You will get to know the information in the coming minutes. Fine. When we see to this, we have still more flabbergasting information. I spoke about photosphere, chromosphere, corona. Do we have any other characteristic of sun? Definitely. One will be bothered about solar wind. The other may be bothered about solar prominence. The other may be bothered about space weather or solar weather. So we have solar wind, solar flares, solar prominences, and solar weather. So these images clearly depict those information. So you can clearly understand the concept of solar prominence and solar flare. All right. After knowing few stunning information pertaining to sun, it is the high time to take up the eventuating, the most fascinating topic, Aditya L1 Mission. Why exactly this Aditya? You all know that Aditya is analogous to sun. In English, it is sun, universal star. In Kannada or some other language, we normally refer sun as Aditya. That is why purposefully Indian Space Research Organization has embarked the name Aditya for this solar mission. All right. To know about the objectives of Aditya L1 mission, we should be aware of this information. When you see to this image, majority may not be in a position to know what exactly is this. This is coronagraph. I spoke about corona. Now it is coronagraph. Why I need to focus on coronagraph? If a solar astronomer is bothered in seeing to solar corona, he or she should be well versed in operating coronagraph. This is basically a telescopic attachment wherein one can see to solar corona very easily. That is why this image has been projected. Fine. In addition to solar wind, solar flare, solar prominence, we have yet another characteristic of plasma depiction, that is coronal mass ejection. You may be just in a state of pandemonium. Why all this information are relevant in this particular webinar? I will tell about that. Yes. Now I am coming to the actual topic. After having a elegant discussion about the sun and the related information, now I have to take up the exact session on Aditya L1 mission. I just said Aditya is analogous to sun, or sun is synonymous to Aditya. This L1 mission, most ambitious venture to sun, this is what they conceptualized plan of Aditya L1. Actually speaking, in 2008, it was conceptualized by the Advisory Committee of Space Research. ISRO started thinking about the venture towards sun. Please remember, if you wish to embark any space mission in 2020 or 21, you cannot plan in 2019. It's highly impossible. So almost about a decade you require for planning, design, implementation, and execution. So please remember, in 2008, it was conceptualized by Advisory Committee for Space Research. Initially, it was envisaged to have about 400 kg weight with the overall budget 50 crores. But please remember, this space mission, solar space mission, is planned to embark or launch during 2021 or 22, depending on the existing situation. So most likely 2022, they will definitely plan to embark. Fine. To know about more pertinent information about Aditya L1 mission, we need to know many more thoughts. What exactly the launch mass and payload mass of this? Who is the developer? Who is the manufacturer? Those information we need to know. This is undoubtedly the plan from Indian Space Research Organization and associated research institutes. Additionally, along with ISRO, Indian Institute of Astrophysics, Inter-University Center for Astronomy and Astrophysics, Physics Research Laboratory, Vikram Sarabhai Space Center, Udaipur Solar Observatory, and a laboratory for electro-optic system have joined hands together in developing the payloads. You please see to this, you will get many astounding thoughts. All right, to know about payloads and other specifications, we have time. Just now I told many research institutes are supporting ISRO in embarking this solar space mission, right? What is the launch mass? The launch mass is estimated to be 1,500 kg and the payload mass is about 244 to 250 kg. Also, you may be wondering which rocket will be responsible in embarking Aditya L1 mission. It is undoubtedly Polar Satellite Launch Vehicle PSLV XL. That is what we wish to know in the beginning. Fine. I was speaking about coronagraph. For any solar space mission, the telescopic attachment, coronagraph is very important. This particular image will help us in understanding the principle of operation of coronagraph in a very simple way. Fine. This is one of the most celebrated images wherein the use of coronagraph, spectrometry, spectroscope, spectrophotometry can be understood. Please remember, we follow 4 techniques or festoon any solar space mission with 4 instruments. Let me repeat: spectrometer, spectroscope, coronagraph, and solar photometer. Please remember these information in a very scrupulous manner. Fine. This is what the exact image of the instrument coronagraph. In this webinar, in Aditya L1 mission, it is very much mandatory to know about the instrument telescopic attachment coronagraph. Fine. At this moment, you may start wondering where exactly this coronagraph will be festooned. Where exactly will this be available? Friends, in India, we find 3 prominent observatories, solar observatory. One at Kodaikanal Solar Observatory and one at Udaipur. We have 2 solar observatories, one at Kodaikanal and other at Udaipur. In both solar observatories, we find coronagraph. Additionally speaking, at Yeris Nainital, Aryabhatta Research Institute of Observational Sciences, so they have coronagraph wherein the attachment we will find from Hanle Indian Astronomical Observatory at Ladakh, and the other one, Hoskote, we have CREST. So they will operate very spontaneously or judiciously in understanding the style of functionality. So please remember the operation of coronagraph from solar observatories, they are very, very important. Fine. This is the person who is responsible for inventing the first ever coronagraph in 1931 is none other than Sir Bernard Ferdinand Lloyd. So Lloyd's coronagraph is very, very popular. Fine. This is what the artist impression of Aditya L1 space mission. This is one of the images wherein we can see to some of the information relating to Aditya L1 mission. In the beginning, I told about the launch mass, then a payload mass, then which is the rocket responsible for embarking Aditya L1 mission. So this is the one wherein we will get some information relating to Aditya L1 space mission. Okay. What exactly this image referring to? You will all be amazed. Aditya solar mission will be okay. What is this L1? Why exactly the alphabet and the number have been used here? Yes, you have a point. I'll come to that. Please remember, this is the first solar mission from India. So, majority of the space scientists and astronomers are very much confident in embarking this space mission. Okay, I told that somewhere during 2021-22, this space mission will be embarked. Where exactly? What is the venue? Friends, Chandrayaan 1 and Chandrayaan 2 have been embarked from Satish Dhawan Space Center. So it is very much evident that from the same site, this space mission will also be embarked. We will see what other information are very much important in this webinar. Okay, I told about the specifications. I gave a simple idea how exactly the space mission will be. There are many more technical information wherein it may be very difficult for a common person to understand. Once, when it is successfully embarked towards sun, all will be in a position to know each and every feature, vitality in a convincing manner. But this is not the time to reveal any of the secrecy pertaining to that. We have to just know the information at the surface level. Fine. This is all available in any portal, any space portal, but comprehensively we should know. Fine. This image will help us in knowing which are all the payloads incorporated, which are all the prominent payloads that have been planned in Aditya L1 mission. Friends, please remember there are 7 payloads that have been incorporated in Aditya L1 solar space mission. So this tabular column will help us to know which are all the payloads that have been planned to incorporate. Fine, we shall know each and every information in a very lucid manner. Before going to the payloads, which are all the very specific payloads that have been incorporated, one other feature what we need to understand. We came across the concept of solar wind, solar flares, prominences, solar weather. When you just see to these lines of forces, it is very much evident that strong magnetic field will relay the surface of sun. You all know that the surface temperature of sun is about 6,000 Kelvin. But the internal temperature of sun will vary from 11 million degrees centigrade to 15 million degrees centigrade. You just imagine what sort of strength magnetic field will be induced in that. Friends, you have to know some information regarding the exertion of magnetic field. In the polar field, 1 to 2 Gauss or 0.0001 to 0.0002 Tesla of magnetic field will be induced. But in the main part of sun, the value is absolutely unassailable or incredible. The range of magnetic field will be extraordinary. It will vary from 2,700 to 3,000 Gauss or 0.3 Tesla. That is amazing. So the magnetic field exerted will be very much pivotal in the exertion or the liberation of solar radiation. All right, this is yet another image wherein one can very easily, effortlessly understand the development of magnetic field in sun. Okay? Help us to know a very important concept. Aditya sun, okay. Solar space mission, fine. Why that alphabet and a number has been incorporated? Friends, you will see to this image wherein you find 5 important points, L1, L2, L3, L4, L5. What is that alphabet L? L is the Lagrangian point. So very specifically to Lagrangian point 1, this particular machine will be embarked on. That is why very specifically, very categorically, Aditya L1 Mission. Please remember, L is the Lagrangian, 1 is the point. How exactly this Lagrangian was conceived? This was named after Pierre-Joseph Lagrange, one of the famous French mathematician, physicist, and astronomers responsible for the phenomenal achievements in these areas. So named after Pierre-Joseph Lagrange. All right. This image was projected earlier also. Now it is the time to know the information pertaining to 7 prominent payloads. This is very, very important. It may be available in many other web links or websites, but this particular session will definitely have strong persistence towards the comprehension of Aditya L1 objectives. just directly focusing on the payloads will not gain any sort of information. Anyhow, payloads are very important. But what are the strong objectives of this space mission? We could understand the specifications. Then, just now I told 7 payloads are very much relying on their solar space mission. But which are all the objectives favorable, friends? When we just speak on Chandrayaan mission, it is very evident. Chandrayaan mission will explore the characteristics of moon. But how about this Aditya L1 mission? Even though there is a plan to move this particular mission, solar mission to sun, the prominent objectives, the prevalent objectives are to explore very specifically solar corona. In the beginning, I gave emphasis for corona. You were all in the state of discombobulation. Why exactly this resource person is speaking on solar corona? He is speaking on total solar eclipse. No. Now I am connecting the information. The first and the foremost objective of this mission is to explore the diagnostic parameters of corona, spectral imaging of images of photosphere and chromosphere. Later on, to study the coronal heating process, solar wind acceleration, coronal magnetometry. Next, monitoring ultraviolet radiation, and eventually the dynamics of solar atmosphere. So these are the imperative objectives of solar mission Aditya L1. Now, it will be very easy for us to know why exactly the 7 payloads have been incorporated, have planned to be incorporated in Aditya L1. Let me start that. When you see to this very prominent image, you find the abbreviated form VELC. What is this acronym? It is Variable Energy Line Coronagraph. In the beginning, I strongly emphasized coronagraph is very important. That is why to analyze the diagnostic parameters of solar corona and very specifically to study the origin and dynamics of coronal mass ejections, VELC play a very dominating role. The first payload that have been planned to festoon in this solar mission is VELC. All right, the second payload is SUIT, S-U-I-T. What is this? What exactly the acronym? Solar Ultraviolet Imaging Telescope. It is very much clear when we just come across the term ultraviolet. What exactly is that? This payload has the potential to image photosphere and chromosphere in the ultraviolet region depending on the wavelength. So, solar ultraviolet imaging telescope is the second payload of Aditya L1 mission. Fine. Few other payloads you may not be in a position to see to this in this particular image. Let me tell that the next one, aspects. What exactly this aspects? Aditya Solar Wind Particle Experiment. The first one was VELC, the second one SUIT. The third one, the third prevalent payload in this mission has just revealed aspects. Aditya Solar Wind Particle Experiment, which has the potential to explore the properties of wind and also to study the energy distribution. Fine. The fourth one you can find to the left side, PAPA, Papa. What exactly is that? For any child, Papa is very important. Here also, this Papa is extraordinarily important. What is that actually? It is the plasma analyzer package for Aditya. This is the fourth payload that have been planned to festoon in this Aditya L1 mission. The remaining three, they are SOLEX, SOLAX. What is that actually? Solar Low Energy X-ray Spectrometer. So just studying solar corona, the characteristics of photosphere, chromosphere, next coronal mass ejection will not be sufficient. In addition to that, the properties of solar wind, the behavior of solar wind will also be studied. So, SOLEX and Helios, the sixth payload in Aditya, HEL1OS. That is not I, that is 1. High energy Lagrangian point 1 observational X-ray spectrometer. That is the acronym for Helios. The last payload is undoubtedly magnetometer. Magnetometer, that payload has the potential to measure, determine, and also to assess the interplanetary magnetic field. So please remember, these are the 7 payloads that have been planned to be festooned in Aditya L1 mission. Right? Just knowing the payloads specifications will not be sufficient for us. You will ask a question, who are all the other research organizations, institutes that are highly supporting, they are favoring ISRO in this ambitious venture? I'll come to that. Friends, when I emphasize the salient objectives, I mentioned about the study of solar corona, the spectral imaging of it, then taking the images of photosphere, chromosphere, study the origin and dynamics of coronal mass ejection. Next, I spoke about solar wind, solar flares, solar prominences. We have yet another objective, solar weather. How exactly the weather conditions or the atmospheric conditions will favorable or will be favored to the planet Earth. So that is also one of the objectives that will be explored by Aditya L1 mission. Okay. I spoke about the 7 prominent payloads. Those payloads, they are comprehensively festooned in Aditya mission. But now I will show 7 particular images wherein you may understand the direct principle of operation of each and every payload. The first payload, what I mentioned was variable energy line coronagraph. This particular payload will be encumbered by the telescopic attachment coronagraph. So just in about a minute or two, you will not be in a position to understand the principle of operation. But this is one of the images wherein you will have some idea about the first payload. Right? The second one, I mentioned that as SUIT, Solar Ultraviolet Imaging Telescope. I clearly said that this payload has the potential to take the images of photosphere and chromosphere in the ultraviolet region. So this payload has that potential. All right. The third one, I clearly said the abbreviated form aspects. What is that actually? Aditya Solar Wind Particle Experiment. This is what the image wherein one can understand the essential features, the components in the payload. What exactly the objective of this payload? As clearly indicating solar wind particle experiment. So this payload has the potential, has the ability to explore the properties, behavior of solar wind, followed by how exactly the energy distribution takes place. The next one, it is very evident, Papa, the plasma analyzer package for Aditya. The name clearly indicates plasma. This payload has the potential to clearly study the distribution of plasma. The aura of plasma is a very essential characteristic for Sun. The last three payloads, the fifth one, I revealed already. This is SOLEX, SOLEX, Solar Low Energy X-ray Spectrometer. In the beginning, I clearly said the four instruments are very vital in any sort of solar mission: coronagraph, spectrometer, and coronagraph. So here you find X-ray spectrometer. This is low energy. The penultimate payload, this is the setup of Helios, high energy Lagrangian 1 observational X-ray spectrometer. This is the high energy spectrometer. The last one, it is very, very obvious, magnetometer. In any solar mission, without magnetometer, you will not be in a position to assess the intensity of magnetic field. So here, this magnetometer has the potentiality to measure or determine or assess the interplanetary magnetic field. Okay, now for about another 10 minutes, we should have some more information regarding Aditya L1 mission. Friends, very preliminary information. The spelling of Aditya should be ADITYA. Some pronounce it as Aditya, THYA, but for this space mission, the accuracy in spelling should also be very important. This is Aditya L1 mission. Okay. You may all think that the speaker may be deviating from the subject. What sort of building is this? Friends, I spoke about the specifications, objectives, payloads, but I have not clearly mentioned or specified which are the other research institutes or organizations with ISRO supporting this venture. To begin with, this image will give the information about one of the very popular astronomical and astrophysics organizations at Bengaluru, that is Indian Institute of Astrophysics. That is in Koramangalam, Bangalore. This organization has supported in designing and fabricating the first payload variable energy line coronagraph. Okay, this is IIA at Bangalore. This is the world famous organization, yet another world famous astronomical organization at Pune, Inter-University Center for Astronomy and Astrophysics. This is very popularly called AYUCA, Pune. When we just tell about AYUCA, you will definitely remember a world famous scientist who has worked with Fred Hoyle and Thomas Gold. I think you're getting the idea, Dr. Jayant Vishnu Narlikar. So this is the organization wherein this is strongly associated with ISRO in designing, developing, and fabricating this second payload suite, Solar Ultraviolet Imaging Telescope. The third organization, it is clearly mentioned in the image, Physical Research Laboratory, PRL. This has taken the pivotal role in developing and fabricating the third payload in Aditya L1 mission, that is clearly mentioned aspects, Aditya Solar Wind Particle Experiment. Fine. This, I think, majority might have seen at Trivandrum. This is named after a world-famous Indian space scientist, the promulgator of Indian space program, none other than Dr. Vikram Ambala Sarabhai. This is Vikram Sarabhai Space Center. So this space center has taken the instrumental role in developing and fabricating the fourth payload, PAPA. I have clearly given the acronym for that. Next, the fifth and the sixth payload that have been designed. So majority of the work might have done. It is almost in the verge of completion. ISRO Satellite Center have taken the privilege in designing and fabricating the fifth and the sixth payload. Low energy X-ray spectrometer, and the penultimate one, high energy X-ray spectrometer. Please never forget L1. Lagrangian point 1 is very important. Just when you browse the information about the Lagrangian points, you will understand the depth of astronomy and space science. Okay. When we just see to this in association with ISRO Satellite Center, Udaipur Solar Observatory has taken the initiative in designing HIL1OS, High Energy Lagrangian Point Observational X-ray Spectrometer. So this is one of the beautiful solar observatories you find in India at Udaipur. Udaipur is a wonderful city. If you visit Udaipur, never forget to visit Udaipur Solar Observatory. This is in a small island. Then lastly, this is yet another flabbergasting honeymoon spot, Nainital. In this spot, you find a world famous astronomical organization or an institute, ARIS. Aryabhatta Research Institute of Observational Sciences, wherein Dr. Dipankar Banerjee is the director. So this is in a very serene place. It is in a hillock. When you explore here, you will see to all sorts of astronomical instruments. Okay. This is yet another image of the world famous astronomical observatory ARIS at Nainital. So these are all the prominent research institutes that have taken the initiative in joining hands with ISRO in embarking the most ambitious solar mission, Aditya L1. Okay, I'm almost coming to the end. The last payload, you all remember, magnetometer that has the potential to measure the interplanetary magnetic field. That particular payload has been designed. It is almost in the verge of completion. This initiative has been taken by Laboratory for Electro-Optic Systems. So these are all the various research institutes one has to clearly remember. All right, I'm almost coming to the end of my session. You will be wondering, what exactly is this? Is this the conceptual view of Aditya L1? Friends, in the beginning I told Aditya L1, even though this is the first solar mission, but remember, this is the second space astronomy based satellite. Which was the first one? On September 28, 2015, yet another satellite was embarked by ISRO. That was ASTROSAT. The main objective of that mission was to explore the characteristics in the binary stars, namely neutron stars and black holes. That was the main intention. But remember, even though Aditya L1 is the second space astronomy based mission. This is the first venture to Sun by India. So that is why I gave a comparison with ASTROSAT. This is what the image of yet another ambitious venture from ISRO, that is ASTROSAT. You can just peep to the various components in this. We can find soft X-ray telescope, then scanning sky monitor, then a cadmium zinc telluride imager, and lastly, very important, ultraviolet imaging telescope. Okay, so even in the Aditya L1 mission, we find the first two payloads, very important, that suit solar ultraviolet imaging telescope, that is very, very important for imaging photosphere and chromosphere. Likewise, we had the same incorporation in ASTROSAT. Fine, we are almost coming to the end. We could gain many information regarding the objectives, but very important, solar weathering. In order to correctly understand the favorable weather conditions around sun, whether will it have impact on other exoplanets or not, we don't know. So this space mission may have the potential to explore that. Fine, this is one of the images wherein you can understand how exactly a weathering system operates. Okay, Aditya L1 mission is very important, but when I spoke about the information relating to ASTROSAT, ASTROSAT was supported by a rocket PSLV C-50 or C-30, whereas which rocket will support Aditya L1 mission? It is undoubtedly PSLV XL. So this is what the image of the rocket that will support Aditya L1 mission. Friends, this is the time to conclude my session. Abruptly concluding will not help few participants. We shall have an epigrammatic summary for about a minute very quickly. Anyhow, Aditya L1 mission will be one of the most ambitious ventures in this millennium, undoubtedly. Even though Chandrayaan 1, Chandrayaan 2, MOM, ASTROSAT have been embarked by ISRO, so this will be the most challenging for the scientists, engineers, and architects of ISRO. So this has been planned to embark during 2021-22, depending on the situation. So almost the work from ISRO is almost in the stage of completion. Still, many more things have to be initiated. We shall hope for the best. How exactly this space mission will fruitfully function. Okay, friends, this is the time to conclude my session. I take this great privilege and opportunity in thanking Vidyavardhaka College of Engineering and the management of Vidyavardhaka Sangha in giving me a wonderful opportunity in talking to you all about the most ambitious venture to Sun, Aditya L1 mission to you all. Additionally, I have to thank the Department of Civil Engineering. I have to predominantly thank the head of K. Prasad in giving me a wonderful opportunity in sharing information regarding Aditya L1 mission. Additionally, I have to thank Professor D.P. Mahesh, Professor Anjan B.K., Professor Madhushri, and all other adorable colleagues of this esteemed institution in talking to you all. Thank you very much.
Mohan Krishna sir, there is one query from the participant end from Anand Prabhakar. And the query is like this: Sun is very hot, thousands of degrees centigrade. Would Aditya L1 can face such high temperature range? And if yes, then how? Hello sir, am I audible? Mohan sir?
Yeah, you are audible.
Sir, there is a query from participant end from Anand Prabhakar. The query is: Sun is very hot, thousands of degrees centigrade. Would Aditya L1 can face such high temperature range? If yes, then how?
It's a very good question. As said in the beginning, Aditya L1 strongly focus on the Lagrangian point 1. The distance between Sun and Earth, as told in the beginning, it is 15 crore kilometer. This space mission, even though it is a low Earth orbit mission, it will be in the proximity of around 800 kilometers. If you wish to explore the diagnostic parameters of solar corona, photosphere and chromosphere, and other characteristics of Sun to the closer proximity of Sun. If it enters the main part of Sun, that will explode. So please remember, there is relative larger distance between Sun and Earth. So that is why very particularly Lagrangian point 1. When you please explore about how exactly that Lagrangian point 1 is indicated, you will understand. So that is what the information I wish to convey.
Thank you, sir. There is one more query from Rahul Arora. What will be the material of Aditya L1?
See, normally Aditya L1 mission has to be designed using variety of materials. Initially, they have to use aluminum, carbon steel, soft steel, stainless steel, and many high degree materials. So just one element or metal will not help in fabricating. There should be assortment of nearly 40 to 140 materials.
Thank you, sir. That's it from the participant end. I now request Professor Dr. Shilpa V.S. to deliver the vote of thanks. Over to you, madam.
Thank you, Madhushri. Good evening, one and all present. As we have come to the end of today's webinar on Aditya L1 Mission, the most ambitious venture to Sun. It's my privilege to propose the vote of thanks on this occasion. On behalf of our department, I express my heartfelt thanks to the today's resource person, Dr. S.A. Mohan Krishna, Associate Professor, Department of Mechanical Engineering, VIDYAVARDHAKA College of Engineering, Mysuru, for enlightening us on Aditya L1 mission. Thank you, sir. It was very interesting. I take this opportunity to express our sincere thanks to members of management VIDYAVARDHAKA Sangha and our principal Dr. B. Sadashivegowda, who are always been the great support for conduction of such events. It is a matter of immense pride for me to convey my gratitude to our HOD, Dr. S.K. Prasad, for his continuous support and motivation in conducting such events. Thank you, sir. I would also like to render for giving me this opportunity. I extend my heartfelt thanks to Professor Anjan for helping in broadcasting this event, and all my fellow colleagues, technical and non-technical staffs who helped in conduction of this event. Thank you all. I would also like to thank all the participants for their active participation, and we also look forward for your continued support in our future endeavors. Thank you one and all. Stay home, stay safe.
Thank you, madam. Thank you all the participants for your active participation. I'm Madhushri signing off as Master of Ceremony. Thank you, everyone.